Switzerland was super cool. The weather was about exactly like this. Everything was very meticulously on time. It was awesome. You walk anywhere you want, and there was really good public transit. You can get around. And there's a really cool conference I went to called, do you guys remember? No, it wasn't Kai. Kai's usually in the spring. It's computer-human interaction. We do computer-human animal interaction, CHI, which is a nice acronym, right? Kind of nice. No, this was a conference called Ubiquitous Computing, which, have you guys ever heard the term ubiquitous computing before?
You said it.
I said it? So, it kind of came from, there's this guy named Mark Weiser, and they kind of looked at how computing is typically used. So do you guys remember back in the day, you would have, in the 60s, the 50s, what was the relationship of a computer and a person?
One computer to many people.
Oh my gosh, she's seen this before. So you got your one little computer there, right? And you got a zillion different people, and they all try to use it. Boom, 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 boom. Then something happened in the 80s and 90s. What was the kind of new way? Personal computers. So you have how many computers, you think? One. How many people? 1,000?
One.
Oh, just one person. So you have this one person, one computer kind of thing. Then while this was going on, they kind of saw that the new development would be, what do you think? What do you think?
One person, multiple computers.
Oh, one person, one fat, happy, rich Westerner, right? Surrounded by tons of technology. You got your phones, you got your PDAs. Maybe you don't have your PDA anymore now that you have a smartphone. You got your laptop, you got your TV that talks to you. You have light switches that tell you what the weather is like outside. You have all kinds of different stuff. So it was about exploring this design space of one person, this is a person, to kind of many computers. And of course, this type of model is maybe up for debate. I'm more so interested in maybe not a person, but the environment and just how we can change things by adding behavioral tools in an environment that let us or the animals or the plants experience life in slightly different ways that they weren't able to before. But that's kind of the basis of this ubiquitous computing conference that I was at. What can we do now that maybe computers are getting smaller and smaller and we have much more of them, and we have computing more so distributed in the environment instead of encapsulated in one huge box? So there's a lot of people discussing stuff like, I think you guys scoot from. So there's lots of people discussing a lot of mobile stuff. So a lot of people, you say the words ubiquitous computing to them, they're like, oh, okay, yeah, mobile phones. There's so many papers presented at this conference. First thing they say is, nearly every person has a smartphone, which, first of all, is either just completely untrue or kind of reflects that they're feeling that maybe people who are very impoverished or live in societies where nobody has a smartphone, they're not really people. So I kind of took offense to some things like that. But it's kind of this given in a lot of our rich westernized societies that, yes, lots of people have an amazing device that can give you access to tons of information nearly instantly, wherever you are. However, there's been more and more people going to these conferences who are kind of trying to see beyond just kind of screen encapsulated computer devices that happen to be smaller. Maybe lots of people have them. So a lot more embedded sensors and all kinds of weird, crazy stuff. I'll show you guys a video. Actually, I'll show it right now. Because this is one of my favorite things that I saw there. And this was kind of a much different view of lots of, there we go. This is a much different view of perhaps a design space that's not just letting me communicate with my friends more efficiently or effectively or getting my business kind of done. This one presented just a weird set of ideas for experiencing stuff that you wouldn't really be able to otherwise. One of the most important things about this project for you, though, is I want you to look at how well done their documentation video is. At the end of the semester, you guys are all going to be presenting projects of your own. Chances are these projects are going to be complicated, they're going to be super experimental, they're probably going to fail and break and not really work. I, at UbiComp, presented one of my weird devices for being able to smell in stereo. This thing got all busted up by the TSA. Stuff happens. Everything's going to break. So the way that have you guys ever taken math class before? Yes, right? So in the math class, you don't just, it's your final exam. You don't just show up all baller to the final exam and just be like, yeah, 28, and just turn it in. And the professor's like, well, the answer was 28. But what do they want you usually to do between the answer? Show your work, exactly. 99% of all the credit you're going to be able to get in from doing design work of any kind in your life is going to be in documenting your process. Because you're going to spend tons and tons of time, especially when you have to do stuff like code and things like that. People aren't going to care if you turn in this thing and it's all broken and in a box and they're just like, okay, great. But if you have something that documents the process that you went through of exploring this, showing where you failed, showing where things broke apart, showing where you learned things about how materials work and stuff like that, that's where you're going to get all your credit in a job interview and discussing tech with some sort of person, and just sharing designs with the community at large. It's all about documenting your work. It's very important. And like I said, everything will break and fail. So these group, they're from Japan, and they present a very wonderfully documented project. And so this is the kind of like fleshed out documentation that I'm going to want to expect from you guys at the end of the semester. And it's just wonderful. So let me start playing it and see if we have sound.
Second, please.
West kind of snow.
Rose.
Use those rolls.
Subtitles are important on documentation videos because you might be presenting it to an audience that doesn't speak your language. It can be easier for them to parse that.
First, we experimented projecting images towards mist. We tested dry ice, steam, and smoke liquid. Considering safeness visualization,
All different things that they tried
we
out.
chose smoke liquid. Next, we implemented a soap bubble generator. At the same time, we succeeded in encapsulating the smoke in a soap bubble. At At this point, we created the Central Operation Center, COC, which integrates soap bubble controller. This unit includes the following modules: a contra-rotating fan which controls soap bubble size and speed, relay of smoke liquid launcher and its control, ring module for supply soap bubble liquid, maintaining soap bubble temperature by using halogen lamp and LJ module, absorbs extra smoke to return to reservoir, power management module, voice system. Here, the input interface uses speech recognition library called Helio. Decoration. Here, we detected the soap bubble by using a depth camera. In this way, we can project an image toward the moving soap bubble. Also, we change the interactivity of animation by detecting when the soap bubble bursts. Moreover, we created the Bubble Control Unit, BCU, by implementing the following two approaches. First, electric induction. By negatively charging the bubble and the column supporting the equipment, we succeeded in making sure that the bubble does not come in contact with the column. Second, control by fan. This trial conveys a bubble to arbitrary coordinates by 8 small fans and 1 medium-sized fan based on the position information detected by the depth camera. This work is still in progress. We implemented Pipette Dispensing Unit, PDU, which makes its fragrance. By utilizing 2 arms, spin axis control, and a setter, this equipment can suck up and discharge fragrance as well as dispose the used tips on arbitrary coordinates. In this demonstration, PDU dispensed cream into coffee. This unit links to a computer by using Arduino.
When you're making something, it's
This
often going to
PDU
be
is merged by BCU and COC
that you'll
and
need to do a
controlled
lot
by
of proof of
computer.
concept tests with something that's not even related. So
In
picking
this
up
way,
some
Cybiotic was
coffee
created.
dispenser.
Come in, please.
West minus no.
All right.
Controls always.
Right.
So that was fantastic, right? You kind of got an idea of what the thing does, but you also got a real sense of all the different effort that they put into it, stuff you wouldn't be able to really think about if maybe you just saw a quick demo of their video running. So just like, wait a second, how do they keep the bubble from hitting the sides? The bubble control unit is one of the most brilliant things that is from this project. Obviously, it's a very rough early thing. It's this thing that kind of poops out a little bubble, and then it's in your room. But they project all kinds of other ideas like the projection mapping that you can use for it. All kinds of cool stuff. And let me show you one thing. The guy who made this thing, he just came up to me at the middle of a conference. The guy didn't speak any English. And he's just like, I have this kind of thing. And he shows me his journal. And his design journal was amazing. My laptop's charging up. But I'm gonna have you guys in a second start discussing some of the readings with each other, and then we're gonna do like quick 15-second presentations of those. But while we do that, I'm gonna show you this guy's journal too. I'll be coming around with it. One last thing before I have you guys do your reading stock. Your ambient video of the day. This comes from a bioperformance of my own. This was, have you guys ever read anything by Alan Capro? Maybe if you were in Michael Nitzsche's class. Capro was kind of the creator of Happenings and very lifelike performance art, where you just go and you just do something in the real world, which becomes kind of inspiration for these bio-performances that you guys are doing.
We did a happening last week.
Oh, in Cecilia's class? Or Celia's? Yeah, Chris Delion with his clouds are great. Yeah, exactly. So that's from, oh yeah. Chris is an amazing human being. So those are all inspired by Alan Capro. He's a big leader in kind of this performance studies literature about the value of, just going out and performing these things. So when I was in the jungle this summer, I had kind of two main people that I worked with. One was Peter Martin, who studies ants. One was Antonio Hubancheva, who's a Bulgarian bat girl. And I challenged them. I had many challenges for them. And one of them was I gave them kind of a list of different works of famous performance art, and they were going to try to recreate them in the jungle. So one of them took one of Capro's works. They actually both took one of Capro's works. One was called Fluids, and in Fluids, which is in your inspiration book, that's where you guys should have all, oh, my ears are perking up because I totally read that book that Andy thoughtfully sewed for me. He went around LA and he had these big blocks of ice, and they would just build these big like sculptures and big rings of just ice and just let them melt throughout the day. So we decided we would do a similar thing in the jungle and just kind of see what happened. And so this was one where there's a leaf cutter pathway going through here from outside to in the nest, and we built this big ring of ice, and then we just left it there to see what would happen. And so at first you see they start piling up, and then they kind of form alternate routes around, and it becomes interesting to see like at what point they'll actually forge through the ice itself, because it's a form of matter they've never encountered in their lives. And generations of ants have gone by that have never encountered ice for, potentially like, thousands and thousands of years. There hasn't been much ice in the middle of Panama. So it's very interesting, and, just kind of seeing and interacting with the animals. So that's going on up there. I need all of you, it's been a week. We've had a lot of readings. What were all the readings and videos that I had you guys do?
There was that
Bee video. The ant video too, right? Painting ants.
tutorials we needed to read, which were
What's-
last week.
Yeah,
The tutorials that we had to do.
Yeah, there was like make tutorial. And what was the other one? The intro to Arduino, right?
Yeah.
The make one was like intro to like electricity, kind of, right? Intro to Arduino. And then there's another one. I don't know. What was it?
There was the AT Tiny Arduino and the one with water.
It was also, yeah. Yes. You read Adventures Among Ants, right? 1, 2, 3, 4, 5. 5 of those, 7 of you. Going down in order. 1, 2, 3, 4, 5. 5, 4. Okay? So, from top to bottom, those are your readings. If you're yourself, talk to yourself. If you are a 5 or a 4, you have a new buddy that you're going to talk to about your reading. So you were 4. So you're going to talk about intro to Arduino.
Okay.
You two need to, the people who are talking about your things or talking with them in your own brain, you're going to have 2 minutes to come up with a 20-second presentation where you just kind of stand up here and you talk about the most interesting or salient things to you from that reading. Okay? So 5-second overview, and we'll say, okay, 25 seconds total. 5-second overview, 20-second discussion, let buddy.
Mine was make reading.
I remember. The make reading? Or did I have make? Where's the one you used? Already.
And feel free to ask me if you have questions about things before your big scary presentation. Cool. Anybody have good overview? Yeah, I think that was one of the most interesting parts too. The super cool researchers who were painting on those bees to figure out where they came from. But reenacting an original experiment by Carl and Frisch. Anybody have any questions about the bee video? Were there things like, wait, what?
It's really cool.
Cool.
I
Thank
like
you.
I completely forgot that bees don't use they don't see light the same way that humans do, and they use like a polarizing thing.
Yeah.
And like that's something I would totally overlook.
Cool.
I just always thought it was kind of green though. I went too far. I was like, it smells nice. Yeah. But I didn't realize that like they actually had a communication system.
Yeah, symbolic
Complex.
communication.
That's what it is.
Too. Not even just being like, yeah.
There's some pollen.
Yeah, there's some pollen, but just like, in this vector, you will discover pollen. You know, it's crazy. All right, cool. Let's keep it going, keep it going. Ant painting video.
Okay.
Tell us about it.
Alright, so the paint ants was about painting ants, surprisingly enough. And the researchers wanted a way to identify individual insects. So what they would do is put specific colored dot patterns on ants so that they would know which one was which, because they kind of all look the same. And if there's anything I learned about dealing with insects, is that if you want to do something to them, you drug them, which is what they did in the video, is they drug them.
What did they drug them with?
Oh man, I don't remember
CO2.
specifics.
Yes,
Thank you.
very important.
But
We'll actually see some of this later today. Here's my insect dream.
oh yeah.
Portable anesthetic for insects. And so we keep going through. We'll actually see this in action a little bit later today. So yeah, CO2 works really well on insects to nearly instantly make them fall asleep, but not kill them. If you leave them, they're very good at holding their breath. You can leave insects, depending on the size and stuff, just in a bath of CO2 for like half an hour, and it'll just wake up and it'll be totally fine. Another way that people anesthetize insects is ice water. There's people who they install things on cockroaches. They just literally put the cockroach in a thing of ice water, and it just kind of passes out. And again, it's good at holding its breath; it doesn't drown. And you pull it out, and then do your surgery on it, and in 20 minutes it's back up. I found the CO2 less weird.
Animals that we put in our boxes smell like
Go on.
Can they smell that? And would it make them die?
It depends. It's not going to make them die. It's not going to make you die unless you
Burn it.
burn it, then inhale it. You can inhale it. You just get sick. You don't die. If you just flamethrower into your lungs of the fluon, probably pretty bad.
Okay, so you don't think it affects their
People use it in tons of experiments. Of course, it's always going to affect it somehow. Hence the goal of naturalistic experimentation, doing stuff right in the wild. Anyway, continue, wrap up.
Right.
Okay.
Yeah, it actually reminded me with the thing I did with Drosophila once, but that we used fly gnat for that, and it killed like half of them.
Everybody know what Drosophila is?
What else?
It's a little tiny fly that reproduces quickly.
Yeah. Fruit flies.
Fruit fly.
Drosophila melanogaster. It means
We freed them into the earth.
it means sweet, loving black belly. Okay, so Drosophila, the drosophil part means like nectar, like sweet stuff. Philo means kind of like it. Melanogaster, the gaster of an insect is like the bottom of the abdomen, the butt, or sometimes the belly. So it means kind of like black belly, lover of sweet things. Fruit flies. What was, yeah.
That's what the video reminded me of. They're like, I've been here before.
Cool.
I've poked unconscious insects on my
Nice.
But,
Okay, jump to the next one. Make tutorial. Yeah.
Right, the make tutorial, that was kind of special in that the instructions were to at least skim it, and if you found anything interesting, slow down and read the whole thing through. It was generally just what to have when dealing with things like Arduino, things like that, and things you can do with it. The most interesting part I saw was how to short circuit a car battery and what happens when you do. And that actually does happen. They said it was a simple short, some guy accidentally put his wrench down on both heads, and it sparked and sent his wrench to the other side of the room. Most interesting thing I could find. Besides that, I scanned.
What about other people? Was there any interesting things you found when you skimmed the make thing? You were like, whoa, I didn't know this, or I wish I knew more about this, or I was confused.
I can't remember which one this said. There's a few. Which like tutorial was this one? Maybe tutorial. Like I don't remember.
Well, we'll discuss the next one. If you have questions on either one of them, bring it up. Okay? Leading us to the very next one, the Intro to Arduino tutorial.
Yeah. So that was pretty much what we did on Thursday. With was his name Paul or did I just?
Yeah, Paul.
Okay, no, it's Paul. And so we had to use our breadboards and like use the colors in the breadboard in order to connect wires, nothing like that.
Yeah, we use resistors.
Oh yeah, the resistors, like that's the color, oh, sorry. And the colors on the resistor told us like the amount of ohms. That it represented.
Yeah. Then we use wires and we dip them in like different levels of moisture. So we had like a Starbucks cup full of water. So we would dip it in there and test it, and we use the system monitor on the Arduino to like tell us the output, so we can measure like the differences in it, and then we try to get different resistors to see the number difference, and then we got like a constant state, or what was that called? Yeah. The state, I don't know. Okay.
I just remember that when the two wires were touching, it was zero because that meant it was a short. Zero resistance.
Exactly. So, and what would that indicate? Something wet or not wet?
It's wet, such that it's not complete. And it,
Exactly.
it's wet, it's not gonna be
I think that water doesn't exact perfect.
But you're only, well, okay, if you have.
Only partially right.
Yeah, exactly. Yeah. So anyway, in the circuit that you guys built, the lower number you get, the wetter things are, right? Higher number, drier. Right? Cool. Was everybody able to make this on Thursday?
We kind of worked together, we just
Yeah.
totally
I
understood.
have the
what we were
videos
doing.
of
all of us that I'm gonna send you, or I can show them to you now.
Cool.
Videos explaining what we knew about the resistor to each other and.
Nice job,
I don't know
guys.
whose idea it was to film, but we.
You guys are on top of this.
I
Brilliant.
wasn't there, so that
Ah.
was cool to watch.
Were you able to make it yourself? Like a good, diligent, I skipped class to go for a job interview. Which is a perfectly valid reason, and she emailed me before she went to class, so in case you were like, ooh, that Danielle, she's just skipping town. Bad news. No, so that was all good. Were you able to try to whip something together yourself?
I was not a diligent student. No.
Okay, well, you should. And definitely do that before Thursday, because Thursday we're going to have sensor class. I'm just going to try to bring in as many different sensors and actors as we can, and we're just going to plug them in Arduinos, see how they actually work, all kinds of stuff like that. So today is going to be a lot of talking, catching up day. Thursday is going to be like, boom, 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 boom. Oh, I have all these sensors. Oh, I have this assignment that's due like October 3rd. Boom, 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 boom. Okay, we got to hurry up and do that, okay? So be prepared with that. Look at those emails and links I sent about the tutorial. Cool. Anything else that was like weird that came up during Thursday?
The one problem is that the number of resistors we had were only at 1,000 ohms, which was only in our load for like 60. So I guess Eric had a 10,000 ohm resistor. So we had to put a few resistors like in line.
Do you know what it's called in electronics?
I
You
remember
put
he
them
said
in
something.
theory. Yeah, exactly. Theory.
My God, that's like do that.
Cool, cool. Good, well, good troubleshooting, guys. And then, finally, adventures. What's that?
So, the most interesting part to me was that they don't like quote unquote battle on purpose. It's just like an accident. Their trails cross over each other, and the colony that has more to lose or more on the line, like it's closer to their nest, is usually the colony that plays.
Why would that be?
More ants can like come to help.
They have reason to fight.
Yeah, and they have a reason to fight, you know.
But
Someone's like poking their head around the middle of your house next to your safe. You might be like, hey, get out of here, versus someone just kind of looks weird on the street.
Whatever, yeah. But I thought it was interesting that they weren't like, I guess, seeking out trouble with each other, or were just like across our line crossed. Is that what that meant? I was trying to interpret it a second ago. Like, I think that's what I got from it, is that their lines just accidentally crossed. Or,
Well, it depends on which
here, I'll show you.
which section you're reading. So this guy's great. He studies a lot of army ants and these kind of secret marauder ants that weren't really that well researched back in the day. And by the day, this is one of the most recent ant books that you're going to find. I think this was published in 2005. And so a lot of this, like, usually the research is like when we had the Nico Tinbergen reading, and it was about stuff that happened in like the 30s, right? So a lot of this guy's stuff is like, it's 1995 and I'm poking at ants, so it's a lot more recent.
Also, like, he was just observing what they naturally did and then used that to, like, do it to it.
Exactly, yeah. So this is kind of the part that I wanted, why I assigned it to you. He did some experiments with his ants. You guys, what were the experiments? Do you remember? What did he do with his ants? Not you guys. I know that you at least just looked at the reading, at least in the past 5 minutes. For you guys, who may or may not have even read the reading at all, does anybody know what this guy did? Also, quick show of hands. Who actually read this?
I think I missed this one. I might have read it. I don't remember any of the reading.
Okay, well, make sure to actually read stuff.
I'll read it after.
If you ever have any questions, just go for it. Just because there's a lot of very different subjects that you're gonna have to synthesize. Anyway, this guy wanted to see how they make their trails. So he did lots of different things, which I remember from some of you experimenting with ants. He would leave like cookies or food, and so he would leave like bits of seeds in different ways. He would maybe make a big pile of seeds somewhere and see how they attack that. He would make big arcs of seeds so that no matter which direction they go, they would run into his food cache. So we kind of fleshed out this different ways of feeding and provoking ants through food. Very, very importantly, even if you skipped all the readings, there was a PDF thing that, or maybe a Word document that I posted about good animals for interacting with. You remember that?
Didn't read that.
Started off with something like Andean Barrett's, like, these are some of the best animals you can use. For Thursday, reread that. Because this is going